Welcome to Chapter 5 of Class 7 Science, Changes Around Us, Physical and Chemical. In this fascinating chapter, we'll explore the different types of changes happening all around us every day. From ice melting into water to bananas developing brown spots, from buds blooming into flowers to cold water warming up, changes are constant in our world. We'll learn to distinguish between physical changes, where substances change form but not identity, and chemical changes, where new substances are formed. Through hands-on activities and careful observations, we'll become experts at identifying and understanding the changes in our environment. Let's begin our exploration with physical changes through Activity 5.2. We'll work with paper, balloons, and chalk to discover changes where materials transform in appearance but remain the same substance. When we fold paper into different objects and then unfold them, we get the same paper back. When we inflate a balloon and then let the air out, we get the same rubber balloon back. When we crush chalk into powder, we still have the same chalk material, just in powdered form. These are all physical changes. Only physical properties like shape, size, or state change, but no new substances are formed. Water changing between solid, liquid, and gas states is another perfect example of physical changes. The key characteristic is that the original material remains chemically the same. Now let's explore chemical changes through Activities 5.3 and 5.4, where new substances are formed. In Activity 5.3, we blow air through straws into two glasses, one with tap water and one with lime water. The tap water just shows bubbles, but the lime water turns milky white. This happens because the carbon dioxide in our breath reacts with calcium hydroxide in lime water to form calcium carbonate, a white insoluble substance. This is a chemical change because new substances are formed. In Activity 5.4, we mix vinegar and baking soda, observing fizzing and bubbling as carbon dioxide gas is produced. When we pass this gas through lime water, it turns milky, confirming it's carbon dioxide. These reactions involve chemical changes because the starting materials transform into different substances with new properties. Let's examine two important chemical changes: rusting and combustion. Rusting occurs when iron reacts with oxygen and water to form iron oxide, a new brown substance. This is definitely a chemical change. Combustion involves substances reacting with oxygen to produce heat and light. Remember the magnesium ribbon burning with a dazzling white flame. It forms magnesium oxide, a new white powder. Substances that undergo combustion are called combustible substances. In Activity 5.5, we discover that oxygen is essential for combustion. When we cover a candle with a glass tumbler, it stops burning because the oxygen is used up. Fire safety knowledge tells us that if clothes catch fire, we should wrap the person in a blanket to cut off oxygen supply, but never use synthetic blankets that can melt. In Activity 5.6, we learn about ignition temperature, the minimum temperature needed for a substance to catch fire, which we demonstrate by focusing sunlight on paper using a magnifying glass. Now let's understand the fire triangle, the three essential requirements for combustion. First, we need a combustible substance or fuel, something that can burn like wood, paper, or gas. Second, we need oxygen from the air to support the chemical reaction. Third, we need enough heat to reach the ignition temperature of the fuel. Remove any one of these three, and combustion stops. This explains why fire extinguishers work. They might remove oxygen, cool below ignition temperature, or separate the fuel. Now consider the fascinating case of a burning candle in Activity 5.7. A candle involves both physical and chemical changes. The wax melting, flowing, and solidifying are physical changes. But the wax vapor burning with oxygen to produce light, heat, carbon dioxide, and water vapor are chemical changes. Even the great scientist Michael Faraday used candles to teach about scientific processes in his famous Chemical History of a Candle lectures. An important question about changes is their reversibility. In Activity 5.8, we analyze various changes to see which can be reversed and which cannot. Melting ice can be reversed by refreezing. Boiling water can be reversed by condensing the steam. But chopping vegetables cannot be reversed. We can't put the pieces back together perfectly. Making popcorn cannot be reversed. The corn structure is permanently changed. Burning wood definitely cannot be reversed. We get new substances like ash and gases. We also consider whether changes are desirable or undesirable. Cooking food is desirable, but food rotting is undesirable. Rusting is generally undesirable, but composting food waste is desirable. Context matters greatly when evaluating changes. Finally, let's explore natural changes that occur over long periods. Weathering of rocks involves both physical and chemical changes. Physical weathering includes temperature changes cracking rocks, tree roots growing into cracks, and water freezing in crevices. Chemical weathering involves water and chemicals reacting with rock minerals. For example, black basalt rock can develop red iron oxide layers. Erosion moves rock particles and soil through wind, water, and gravity, creating smooth river rocks and sediment deposits. These processes mostly involve physical changes and are largely irreversible on human timescales. Interestingly, nature also shows amazing chemical changes like bioluminescence in fireflies, where light is produced without heat through chemical reactions. This chapter helps us appreciate the constant, fascinating changes shaping our world, from microscopic chemical reactions to grand geological transformations.